Hello everyone. So today I am Darsh Patel, ID number 20CS046. I am going to present on the topic face detection with sliding window. That is the topic of image processor and computer vision. The subject is guided by Professor Harshul Yagnik sir. So let's start with the presentation. So coming with the presentation, first we'll look at the content that is going to be the roadmap for today's presentation. So first we'll be getting the interview overview of the topic that is phase detection. Then coming with the sliding window technique, then the process of the sliding window technique, that how the sliding window works, then the approaches of the sliding window technique, the process or basically kind of a roadmap or the root process that how the sliding window approaches is worked for facial detection. The approaches generally consist of scanning, feature extraction, classification, training, and post pre-processing. So let's start with the presentation. So coming with the overview of the face detection using sliding window technique. Face detection is a fundamental task in IPCV subject with numerous applications ranging from facial recognition and biometric to augmented reality and emotion analysis. Face detection is used drastically in mobile phones, cameras, and many other electronic devices. So let's get the overview of the face detection in terms of IPCV. So starting with the objective, that the objective of the facial detection is detecting and locating human faces with digital images or video formats is the main objective of the facial detection. Then comes the pre-processing. The pre-processing techniques enhances the images like resizing and grayscale conversions. Then comes the feature extraction. The feature extraction of the face detection technique. Generally, facial features are extracted from the image or the video format that is generated, and that is distinctive face characteristics is matched with them. The patterns or facial characteristics are matched using the patterns like hair-like pattern, LBP pattern, or hog-like pattern. Hog generator pattern will be looking in the today's presentation in future next slides. The classifier is another face detection term. Classifier is a machine learning model that will be using or that will use it to facial recognize or the face recognition in an image. The sliding window technique, a window moves across the image at various scales and position to identify the candidate region. Then comes the non-maximum separation. The non-maximum separation means that eliminates the redundant detection to keep only one detection per face. So multiple outbox or multiple boxes doesn't overlap each other on the same face that is being extracted or that is being detected in image. Then comes the post processing. The post processing means refine results by filtering based on size, aspect ratio, or confidence score. This all the terms aspect ratio, confidence score, and size are pre-given by the user who wants to facial recognize a feature or a video or a format or an image. Then comes the output. Output means providing the location bounding boxes. Bounding boxes means the boxes are generally drawn uh, uh, to showcase the face that is being detected in an image or a video format. The applications are of the facial recognition are many applications that are used in real-time systems, as I just mentioned, in the mobile phones, in the cameras, and in the biometric sensors, etc. The challenges that are come in the facial recognition using sliding window technique are that requires robust algorithms to work on large data sets. The ethical concerns are address issues related to consent, privacy, surveillance, and data processing when using the face detection technology. So moving forward to the next slide, in IPCV, the term sliding window refers to a technique used to analyze an image by systematically moving a small rectangular window or a region of interest. Basically, let's take example. This is an image of 6 cross 4, and this is the slide. We assume this is the slide. So this slide will horizontally move in this direction and covers each and every corner of the image, and using the models which are pre-trained will apply them on the image, and facial recognitions are being done. The sliding window model is conceptually simple, independently classify all images patches as being object or non-object. Sliding window classification is the dominant paradigm in object detection and for one object category in particular faces. For example, modern cameras and photo organization tools have prominent face detection capabilities. Modern cameras are already pre-installed with the face detection that detects the face of a human or a person, and according to that it automatically adjusts the aperture and blur, how much the blur depth is to be given to a particular face and background. So now let's understand the process how the sliding window technique works. So sliding window techniques first captures the image. The image is that needs to be scanned. The scanned image is then further processed to for the feature extractor. The feature extractor is been done using the machine learning models. Machine learning models including SVM, hookbot model is also used. Then a feature vector is classified and non-maxima separation has been done on the same image, and further we can classify the image as a person. So here the person is being detected. So sliding window approaches mainly comes with two approaches. One is hawk detector kind of approach, and another is deformable part based model. So in this presentation, we'll be looking at hawk detector approach. So the hawk detector approach first goes through five phases. First phase is scanning the image. The second phase is feature extraction. The third phase is using the model to apply on the image. The fourth phase is fuse multiple detections in 3D position and scale space. And finally, the object detection is being done using the box plotting where the faces have been detected. The hawk detector. Sliding window detector find object in four very simple steps. The four steps are: the first one is inspect every window. The second is extract the simple features in window. Third is classify and accept wind if score above threshold, means here a non-object or a non-facial objects are also been captured or also been classified. So first we need to classify them as a facial classification and a non-facial or a non-object or a non-human kind of detection. Then we need to clean up the mess, that is known as post-processing. The hawk detector. So coming with the first approach of the hawk detector, first process of the hawk detector, that is scanning the image. The first step is inspect every window. Typically the size of window is fixed. For example, this is the window. This window size is fixed for the image, and this is moved in this direction. That will be covering all the corners of the image, and finally the features have been extracted by the sliding this window. The sliding window, since window is fixed, then how can we find the people at different sizes? So this question is legitimate. For example, in this image, the person here is also a person, but in smaller size as it is far away from the image that is been captured. And here the woman standing is kind of bigger than the person captured in this window. So how can we find people at different sizes in the same image? So for that, shrink downscale the image and slide again, scale down the image and slide the window again. The size of the window is always the same. In fact, do a fully image pyramid. Here is the image pyramid means you just need to convert the same image into smaller sizes, and the sliding detection window size should be kept small, and that should be sliding across the images that we have shrinked down. So make sure the scale differences across levels are small. Do lots of rescaled images so the accuracy of the face detection increases. So coming forward to the next process of the hawk detector sliding window technique is feature extraction. Famous feature descriptor called hog that replaced shift at least for object detection. So there are three steps to compute it. Compute gradients, weighted vote into spatial and orientation cells and contrast normalize over overlapping spatial block. So first we need to convert the image that is just captured into a gradient. Then the image that is converted into gradient should be divided into smaller parts. That is a cell of 8 cross 8 pixels. The 8 cross 8 pixels compute a histogram of the orientation in each cell, and just we need to check how many bins is required to compute that. So here for this image, 9 dim feature vector is used. So this is how feature extraction is done. Features done, we are ready for classification. So now classification technique, we first need to train our model, and only after we can do detection. So first we need to train the model that we will be going to use. For this technique we'll be going to use the SVM model of machine learning, that is a simple vector machine model. And first we need to train that model, and the model that has been trained and ready to predict, then we'll be using on the image to predict the facial recognition of face detection. The detection. Train a window classifier and use the train classifier to predict the presence absence of object class in each window in the image. So coming forward to the next slide, that is training. Several simple steps include in training. Training includes create a fixed resolution normalized training images. That is fixed resolution normalized images are been ready of positive training examples and negative training examples. Then encode images into feature spaces. Feature spaces means we need to convert the images into a grayscale image and convert the image of 8 cross 8 and extract the histogram that I just mentioned in the previous slide. And finally the binary classifier is being learned through using this. So we need to so we'll be then getting the negative window and positive window that we'll be using for the classification of the image. The hawk detector then uses the threshold value to calculate or to consider the block or the square which will be using for the face detection. So run detector on all scales. We'll be need to we'll be running the detector on all scales of the images, and the score which is higher than the threshold, that is threshold in this case is -1. So the score that is higher than -1 and the maximum score will be using that and consider that box. So that is we need to perform the non-maxima separation. Non-maxima separation means it is a greedy algorithm that performs at each iteration, pick the highest scoring boxes as I just mentioned, and remove the all boxes that overlap other than the selected boxes. And finally, the image is been detected with faces. So this is how sliding window technique works in image processing and computer vision. It is an important topic in IPCV. Hope you understand, and please mention or please comment down below any doubts you have. Thank you.